I like this. I also like this. But this sucks. So what about this instead? Okay, to quickly bring you up to speed with this, I wanted to have both metal and jazz word at the same time on a single instrument. You can't have metal without distortion, but playing jazz chord on a distortion amp sounds like ass, as you just heard. To fix that, what I had in mind was to split the string into multiple outputs. To give you an example with an 8-string guitar, the two low strings get high distortion, the mid string get a regular distortion amplifier, and the high strings get a clean amp to do jazz stuff. And the only way to do that was to modify the pickup on a guitar. Not this, but the thingy located on the body of a guitar just underneath the string. They are made out of two main components, magnets and a coil. So a super quick and simplified rundown on how they work. The magnet magnetizes the string gets plucked, the magnetic field of the strings move, which induces an alternative current in the coil, current that is then sent to an amplifier to be amplified. So the main idea to achieve all this was, instead of having a single pickup, we would make pickups for each output of strings we wanted. So the goal is clear, the plan is simple, make 3 pickups, fit them in a guitar, plug them, enjoy. So what went wrong? Of course, before getting to the final projects, you have to go through a certain amount of failures. And while we're at it, let's start a tab on why this project costed me so much. And let's go for the first round of supplies. So I rolled a copper wire for the coil. So I took neodymium as magnet because they're stronger and I thought I would get more output out of it. I took some fiber material to hold everything together, and a bunch of other stuff to make it work. And I also needed something to make the coil. Out of 3 options I had, one was too expensive, one was asking for more trouble, and the third one was a sewing machine. Yep, a simple sewing machine was stable and cheap enough to be the best option out of the 3. Off I go to create the first pickup in my entire life. So we cut, sand, drill, coil, weld, job's done, but it doesn't work. What do you mean it doesn't work? It doesn't work.
Why not, you stupid bastard?
Okay, so here's a list of potential problems. The insulation of the copper wire is not melting when we're welding. Nope, not that. Not enough magnets. Nope. Neodymium doesn't have the right properties. Nope, but still had 2 rows of permalloy on the tab. I will explain later. Not enough turns. Nope. So what's going on? And then, almost as a miracle, after doing all this troubleshooting with no avail, I come and type on YouTube, is carbon fiber conductive?
We can use it in electrolysis, and as you can see here, if we turn the power on,
Shit. So I had confused Vulcan fiber for carbon fiber, one being a great insulator and the other completely conductive. For those who don't understand what's going on here, the electricity was going in the coil, then inside the fiber carbon, but never to the output. While it was a really dumb mistake on my part, it made me go through a bunch of documentation on how pickup works. I could go on forever about what I found, but to keep it simple, the magnet in a typical pickup also acts as a coil, and the attribute you're looking for in a coil is called permeability. And neodymium is really bad at this. That's why during the troubleshooting process I bought something called permalloy, because that have the right properties. But still, you need to magnetize the string for the entire pickup to work. Okay. So, I buy Vulcan fiber on Amazon D. So we build and we get pickup number 1. And here it is, the first multi-output pickup in the world. Okay, so at this point I probably spent 2 months on something that was screeching, bending, barely fitting my guitar, and also the coils were getting sound from neighbor strings and we really don't want that. But with all this new acquired knowledge, I had the foundation to move on to prototype 2. And this time I decided to do 3D printed parts instead of having to cut, sand and everything, because that was taking too much time. So you can add a 3D printer onto the tab. We had a new design that separated core and magnets. So we get in magnets in form of disc and core in form of sheet. This time the coils were parallel to the strings, and we were inserting piece of permalloy between outputs to split them better. I also wanted the coil to be in humbucker. To put it simply, when you run a coil against the other with inverted magnet polarity, you kill some of the noise and hum in a pickup. This was to try to fix the screeching. Alright, so I learned CAD, start to print stuff. Of course it doesn't come perfect at first, but I got better with it with time. To cut the permalloy I brought a Dremel because doing that by hand was taking too much time. Add this to the tab, and also that means getting safety equipment. So we print, assemble, make the call, then weld, then... Oh no. So the plastic in the 3D printer melt at 200 degrees, but that's also how you do soldering and welding, so I needed a new way to connect the copper wire and the electric wire. I thought of using conductive glue, but after experimenting with it, I decided that it was not the best option. But still add those materials to the tab. So I designed a new way to weld outside of the plastic and attach it after. So I build, and there was prototype 2. Okay, so we are getting somewhere. The two strings that were located between the two ass cheeks coils here were getting less sound than the other strings. That was an issue. But the good news is, after testing on just the preamp of my sound cards, I was getting the split right. I didn't get noise from a string that was here inside this coil. So that was good. So the only thing I needed to fix was the two strings that were getting low output. So we're getting on to the last prototype, which is pretty similar to the one you saw, but instead of having 6 coils, we're having 8 coils for each strings. So I tried a special wiring for 3 coils to work in humbuck. That didn't work, so I went back to single coil. And I figured that the screeching was due to the fact that I didn't ground my pickup at all before. So after some more CAD, printing, assembly, coiling, welding, I had the last pickup. And it is installed right there on my guitar, with 3 different jack outputs. Okay, but you said it was a failed project. Yes, it is. And I will explain why. The biggest issue comes down to how a guitar is amplified. The sound gets compressed to L, that means that even the smallest noise gets boosted. So while the pickup works when the signal is just pre-amplified by the sound card, once it gets into an amplifier, you start to have issues. For example, you can't have gates for each independent channels, or else this happens. And the other one is quite unfixable. Basically, you get twice the output of a single string because it gets into 2 different coils, which means that not every string gets equivalent output. To conclude, the signal needs to be void of any external string noise, which is not the case for this speaker. The only way I see it working is to spread the string apart between each output you want. So I called it down and classified as a failed project. But I don't think it's a bad thing in itself, even if I got to spend money on this. I'm really glad I did it, and I've learned so much doing this. In pickup making, electronic, mechanical engineering, and project management. And I think there is still some good thing to be salvaged here. The design I had to create and the knowledge I've got might come handy if I decide to make my own pickups. But for now, I'll be back to be making music, and I'm also prepping a set live with some of my favorite songs to play on stage, go out and have some fun. And I also have other projects like this in mind. So if you like this video, please subscribe and follow me on social media to see what's next.